So 9.7 is the last section of the chapter, and we're finally getting to tessellations, which is what we started out with. And tessellations are going to combine everything we've learned about so far, the rotations, the reflections, translations, etc. And so we're going to be looking at how we can describe a tessellation, also determining whether a figure tessellates, and identifying different symmetries that exist within a tessellation. So our first example here is just talking about what a tessellation is. Think back to the activity we did in class, where you had to take a shape and you had to be able to create this tile where there were no gaps and no overlaps. That is a tessellation. So we have art, we have nature, we have everyday life. This is where we see tessellations. In this specific example, this is a really complex tessellation because we have these turtles and these stingray-looking things that are forming this tessellation in combination with a bird or a duck. So you can see there's 3 different figures here that are all being used in the tessellation. Now what's happening is we're taking these objects and we're rotating them. And every time we rotate them, that's creating one figure, which then can be moved around the picture. So it's a very complex tessellation involving a lot of different things. We're going to look at these 2 other examples. They're a little bit simpler. We want to see what is the figure that is being tessellated and what transformation does it use. Now, it might not just be one transformation. You may have multiple different things that you see. So go ahead and you look at those, bring those to class. Now, this is one of the more concrete aspects of tessellations. It's seeing whether a specific polygon will tessellate. Now, the rule is the sum of the measures of the angles around any vertex must be 360. So that means I must be able to make a full circle around any vertex, meaning there's no gaps. So what we're going to do is we're going to take a look at each figure, and we're going to determine what the measure of one interior angle is. So we need to determine measure of one interior angle. So in this example for an 18-gon, our formula is n minus 2 times 180 divided by n. So you got to think all the way back to that chapter. So I have 16 times 180 divided by 18. If I put that into my calculator, 16 times 180 divided by 18, I get 160. So 160 degrees is the measure of one interior angle. Now what I have to ask myself is 360 degrees divisible by 160 degrees? In this case, no, it's not. There's no way for me to use 2 or 360 degree angles to get that full 360. So does this tessellate? No, it does not tessellate because my interior angle of 160 degrees has no way to form that full 360 that's needed. So you go ahead and you try that for a regular hexagon. And now we're looking at another example of a tessellation. This has a lot of different types of symmetries within it. Because these are all hexagons, they're all symmetric. So what I can do is if I take this particular tessellation and if I were to move it anywhere else on the page, it would just be like a continuation of this tessellation. A way that you can do this is you can just focus in on one part of the picture. So let's do this. Let's focus in on just this part right here. If you take that and if you move that somewhere else in the picture, just move it, it can be mapped onto another part of that tessellation if this were continuing forever. So it does have translational symmetry because you can move it somewhere else and have it actually be part of that tessellation still. It also has glide reflectional symmetry because even if you flip this over and then slide it around, it's still going to be able to fall onto that tessellation. You can also look within it and see if you kind of rotate this piece, can I still get it to map onto that tessellation? It's a very visual thing, so you have to be able to take this and really think about what's going to happen if you manipulate it, if you rotate it, if you reflect it. In this case, because these hexagons are so symmetric, I will have glide reflectional symmetry, translational symmetry. I'll also have rotational symmetry and reflectional symmetry. So I'd like you to take a look at this U try as soon as I'm done going through this example with you. This example, again, is a little bit more subtle. It's just triangles, right? And if I take these triangles, if I look at them, I'm going to focus in on one part of it, just like we did before. I'm going to focus in on just like this section here. Okay, if I focus in on that, if I move this around like left, right, up, down, I can still fall on the tessellation. So this would have translational symmetry. But if I take that and if I flip it, my triangle is going to be oriented differently. So if I flip it like up, or if I flip it over, I'm not going to have the same tessellation. So it doesn't have reflectional symmetry. But I could take it and I could turn it. I could turn these triangles a full like 60 degrees, like this way. And then if I do that, I'll end up with that same sort of tessellation again. So you're going to be looking through these things, identifying what sorts of symmetry they have. So you go ahead, look at that U try. We're going to practice this some more in class, seeing as it is a very, very visual thing.